Welcome to the Stormsurf video surf forecast for the week starting Sunday, October 26th. First up, we'll take a look at significant wave heights for the North Pacific Ocean. Notice seas reasonably high along the California coast, courtesy of a very local gale that developed just 24 hours earlier. Also, a new gale, actually the remnants of Hurricane Anna, tracking towards the Pacific Northwest, and yet another system in the Bering Sea, while the West Pacific remains relatively calm. First up, let's take a look at jet stream level winds. These winds, up about 30,000 feet, help support the formation of storms, and when they do form, also helps direct their tracks. Right now, we have a split jet stream flow, not very conducive to storm development. One path to the south, one path to the north, dead air in between, and no real troughs. That is, a bow in the jet stream to the south. A little bit here in the Bering Sea, but nothing of real interest. What we really see, though, is a trough here. This is moving into the internal U.S. coast. Previously was just off the coast Friday night, Saturday, helped produce a gale that has resulted in seas that are impacting the California coast and starting to fade now. Let's put this into motion, see what happens. The split pattern sort of goes on until about Monday night. Notice a defined trough starting to form. Still split here, but a trough in the northern pair of the jet here with winds 130 knots pushing down into the trough. This is supportive of gale development. As we roll this into motion, notice that trough continues to dig south and winds build to 160 knots by Tuesday night, and then starting to back off a little bit, but then rebuilding on Thursday, and we're back at 160 knot winds. Good, well-defined trough here off the Pacific Northwest Canadian coast and digging further south. That continues, almost getting pinched off into Friday, approaching the U.S. West Coast, and then finally, supposedly, moving onshore late Friday night. This is good, if one believes it, for the support of gale development and likely swell down at lower levels or down at the ocean surface, and also precipitation probably in the Sierra, Pacific Northwest for sure. This is a good sign. Notice also back to the west, this is now by Friday night, the jet has repaired itself, not nearly as split as it was, not very energetic, but looking better than previously. We'll roll this out into motion even further, and here you go, yet another trough is forecast developing Sunday. We're almost 180 hours out now, so that's not real believable, and here we go at 180 hours. And notice this big ridge here, almost looks like it wants to split again, a reasonable amount of energy, and then falling into this trough. So it looks like the Gulf is really the focus right now, and if you really, we'll get into this in a little bit, but the active phase, not even really the active phase, but the Madden-Julian oscillation, what little activity there is centered right here, and typically this is what happens, or actually more down, here we go, on the equator. As the active phase of the MJO works its way across the Pacific Ocean, the apex of troughs typically follow the active phase of the MJO. So the MJO is actually right in about here. This would make perfect sense that the East Pacific is active, that the West Pacific is asleep, and in fact the inactive phase of the MJO is somewhere over in this region. Weak, but it's there, so all this makes perfect sense. Let's go take a look down at the lower levels of the atmosphere. So here we go, surface level pressure, surface level winds. Notice a low pressure here in the Gulf of Alaska. Actually, this fetch right here is the remnants of what was Hurricane Anna just 24 hours ago. It was here north of Hawaii, started to get absorbed in this upper level low that was working its way across the North Pacific Ocean, and is now almost fully absorbed. Even here, 45 knot winds is what the National Hurricane Center was saying, and that looks about right per the GFS. And a little bit of fetch here, but notice not a whole, so counterclockwise circulation in low pressure systems. Some fetch here aimed down at Hawaii on about, I'd say about the 360-degree track, but not a whole lot at the U.S. West Coast. All this fetch is pushing north towards Alaska. Let's put it into motion. Roll it out. Anna works its way towards British Columbia. A little bit of 35 knot winds. I mean, it's good enough for certainly probably large and raw wind swell here along the Pacific Northwest, something less for California. Notice high pressure, 1032 millibars set up over the dateline. Would not be unexpected given the split jet stream flow and the inactive phase of the MJO that we talked about earlier. Roll this out. The, we'll call it extratropical storm Anna moves inland, but a new fetch develops, actually just weak low pressure here. What is that, about 994 millibars, but forming a gradient with the 1036 millibar high here. So winds in high pressure circulate clockwise, winds in low pressure counterclockwise. The difference in pressure between the two amplifies wind speeds, and there you go, 35 knot winds. Roll this out. The low starts falling south, continues the gradient, the high up to 1036 millibars, 35 knot winds by about Wednesday night, falling into the Gulf. Most of this aimed somewhere at targets right about in this area, we'd say. And notice there's wind swell thatch actually aimed at Hawaii here. Continue to roll this out. The low falls south, not really particularly developed. And notice there was an upper level trough right here, or is a upper level trough per the upper level models. Roll it out, 30 knot winds pushing into California by about Saturday. We're not going to get into it here, but there's also a fair amount of precipitation that's supposed to move in with this front right into this area. Well needed. Snow likely also for upper elevations. Probably the first significant snow of the season, if one is to believe the models. Nothing huge, but maybe a foot or so with luck. But that's almost a week out, so you can't believe too much of that. Anyway, high pressure takes over. North winds along the coast, trades for Hawaii, this is all typical inactive phase MJO sort of weather right now, and yet another high, 1032, building back over the dateline. So we're kind of in a down phase right now compared to where we've been since, beginning of September, southern hemi swells, then it rolled right into multiple northern hemi swells. Now we're kind of in a swell here and there, all coming in the Gulf, isolated mainly to U.S. West Coast swell-wise, with sideband energy into Hawaii. So that's the pattern for right now. Let's go take a look at the wave model chart. Significant wave height charts. North Pacific Ocean. We're going back in time a little bit. Friday evening. Notice low pressure, actually a complex low. There's a little bit of low here, another low here. The two of them join forces. Friday night, boom, 26-foot seas. And then by 10 p.m. or 11 p.m. we had 30-foot seas per the models. Clearly the swell that hit was not as big as would be expected by the models, with 30, almost 32-foot seas, less than, is that about 600 miles off the coast? But still, the interesting part here is the models downplayed this and downplayed it all week long. They said it was coming. It actually formed. They were saying, 22-foot seas, maybe 24-foot seas. Last minute, boom, up to 30, 32-foot seas. So that suggests a pattern that we haven't seen for a while. Typically, as we get closer to any weather event happening for the past 4 years, when you finally get to that event, the models continually downgrade, and they stay downgraded. This year so far, the pattern has been the storms form exactly as expected, if not upgrading slightly. This is suggestive of the warm water in the equatorial East Pacific. I don't want to say El Nino, but the warming pattern, maybe we could call it a semi-Madoki El Nino, that's been in influence and having an effect on the atmosphere. Regardless, we roll this out. That swell hit, as you can see, into Saturday night, Sunday, and here comes Anna. Oops, actually, we can actually roll that back, and you can see Anna. This is here. She is here. She built to hurricane force on Saturday and then quickly faded again. That was 65 knots. And then now we're into current time moving forward. Sort of disintegrates. Not a whole lot going on. Maybe a little blast of fetch for Hawaii, but not much. 20-foot seas, small area. This is really wind swell, Pacific Northwest at best. Anyway, that system fades out. Here comes the next one on Tuesday night. 20, about 23-foot seas here, relative to Hawaii. That's the interesting part. There you go. There's 358, so about 360 degrees. Notice it's cutting about the 45 degrees across the Great Circle Path into Hawaii. Anything more than about 30 to 33 degrees, you start losing size. Still, probably a little bit of energy down into Hawaii, but most of us were expecting Pacific Northwest into Northern California. That's 308, 306 degrees sort of thing, at least initially. As this thing rolls out, the models have actually shown higher seas and further south in the previous run. Here we go. This is about 301 degrees, so still pretty much shadowed relative to the San Francisco area, but swell is swell. You take it. You can't complain too much. There's been a lot of it. It's been ongoing. This is more like the steady diet, meat and potatoes that we're into now for this time of the year, which is a good thing compared to years past. And then yet we're into 144 hours. Another little low up here on Saturday in the Gulf of Alaska. It doesn't do a whole lot. High pressure pretty much taking over this region. You can see absolutely no wind and dead seas, and we're at 180 hours. So for the most part, for this week, it looks like it's pretty much more of the same, kind of a bumpy, lumpy, barely swell, wind swell kind of thing, 12, 13 second period, with maybe a little blast from this gale that's modeled here. All right, let's go take a look at long-term, what's going on, El Nino, Modoki El Nino, MJO, all that good kind of stuff. First up, Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. With low pressure over Tahiti, that keeps the numbers negative. Negative numbers suggest at least the active phase of the MJO. If they are negative long enough, they suggest El Nino. Notice a pretty good long stream of negative numbers, particularly negative lately because there's been low pressure hanging right over Tahiti, which is good news. 30-day running average, again, you could use this for the MJO. That's typically the index we look at, minus 7.83. And now the 90-day running average back down to minus 8. This is, again, indicative of some flavor of weak El Nino going on. If it was down around minus 15 or even 20, then you're into stronger El Nino territory. But this is good. Gentle push, consistent. We're just trying to get some momentum going in the atmosphere, all being driven by warm water that's building up in the Nino 3.4 region. That's on the equator in the eastern Pacific. We'll get into that in a minute. But all these numbers look pretty good and are consistent with what's been going on for quite a while. In fact, let's go look at the long-term trend from the SOI perspective. So here we go, 30-day Southern Oscillation Index. Here's this year. In January, we had a massive negative spike. That was the result of, that produced major Kelvin waves, a lot of warm water pushing east. This is really the start of the El Nino thing that we've been seeing. Kind of backed off in May and June, but then another downward spike, and then it's just sort of pulsing along here, and here's the current downward trend. So this is good. I mean, basically, for the entire, once you get below about minus 5, so what's that, January, February, we've been in a pretty good spot. We've had a little bit of a back off here, but right now, looking very good. Notice years previous, 2013, 2012, we just really nothing. Back in July of 2012, we had something we thought was El Nino, and it never really materialized. Now we're in maybe similar, if not better, a longer running negative than anything that was here. These were more like MJO pulses up and down. Now we're just into this steady kind of steady state negative numbers. That's what you want to see. Next, we're going to take a look at 850 millibar winds, differences from normal. 850 millibars is up about 4,500 feet. Most meteorologists use this as an indication of what's going down at the surface. Notice westerly anomalies. These are not necessarily westerly winds, but they're saying that winds for this time of year in this region, there's Australia, by the way, the date line's here, so we're west of the date line, are the anomaly is westerly. This means a relaxation of trades. Relaxed trades result in warm water starting to move to the east. If trades typically in this region blow from the east to the west continually, and they push all warm water, pull it up right in this area. But when you get some sort of either the active phase of the MJO or a prolonged weak active phase of the MJO, which is in fact El Nino, then you get these westerly anomalies, westerly wind bursts, and warm water starts going. The trades reverse or die, and warm water starts pushing its way to the east, which is not normal. Anyway, we go on to the eastern Pacific. Kind of a look at that. Still light west anomalies up across the date line south of Hawaii there. And then things kind of go neutral. So that looks okay. Let's go look a little further out. A week from now, light easterly anomalies are forecast over the maritime continent. There's Australia again, the Philippines here. And then once you get to the date line right here, notice westerly anomalies again. And then we work our way across the Pacific, westerly anomalies almost the whole way across the Pacific Ocean into the Galapagos Islands. The really interesting thing about all this was the models a week ago said, they've been continuously saying, easterly anomalies, never happens. Instead, you get dead neutral or this just consistent, well, I'll call it a low-grade fever, light westerly winds just slowly pushing warm water at depth to the east. Classic, exactly what we want to see. Here's sort of a time-lapse look at that same thing. So here we are. This is looking west to east. The Philippines roughly would be right in around here. Galapagos Islands roughly in around here. The reds, let's go back in time, September 26, are westerly anomalies. The blues, easterly anomalies. Westerly wind burst. September, October, another westerly wind burst, mid-October to almost the end of October, and now the model was forecasting easterly anomalies. Now again, more light westerly anomalies. Nothing huge, but this just continues to feed the pipe of warm water moving to the east. That's what drives the atmosphere, and that's what drives the storms. Next, outgoing long wave radiation model, the statistical model. Suggests the reds, yellows, these are the inactive phase of the MJO. That is more sunlight reflection off the ocean's surface, presumably due to high pressure and clear skies. The blues, less reflectivity, presumably more clouds, and the active phase of the MJO. The model suggests the inactive phase is in play. We'll kind of go with that. Notice because there's no tropical activity in the West Pacific, none really in the East either, and westerly anomalies they're still there, but they're suppressed. They're very weak at best, and the storm track is just kind of not really happening. The statistical model suggests that by 11 to 15 days out, let's say 2 weeks, things return to a neutral pattern. The dynamic model is not as aggressive or not as favorable, suggesting continued inactive phase of the MJO, but we're not buying this at all. We'll say, yeah, that's real, and then this whole thing's going to fade out. And then this model, the upper level 40-day forecast, current, again, it's projecting the propensity to support precipitation at lower levels of the atmosphere. This is up at 30,000 feet. The yellows are effectively the inactive phase of the MJO, no precipitation. The greens are the active phase of the MJO. Notice this model suggests basically just no coherent phase. You could almost draw a line through it here and say the inactive phase, but by Halloween, things pretty much die out and you're into a neutral pattern. And then notice you could see this green pattern sort of working its way east, a very, very light active phase of the MJO. This is very typically what you'd see during an El Nino setup. The MJO disappears, trades disappear, and you just have this steady state, just no trades, no nothing going on, and that's all you need to have warm water that typically is pulled up here continue to slosh to the east, build up a warm pool of water here. That starts feeding the jet stream, and that's what builds El Nino. Next, let's go look at surface water temperatures. Normally we have a chart that shows the entire Pacific Ocean. The site that NOAA supports that has been down for 4 or 5 days now. Presumably they're working on it, and we're hoping by early in the week it'll be back up, especially with all the El Nino hype that's going on. They can't afford to be down too long. But, okay, so again, the area that really matters to us, here's the equator, here's the far West Pacific, there's New Guinea there. The Galapagos Islands are just off here. It's just a couple of degrees either side of the equator that we're really interested in. Here's actual winds, and notice this. Actual westerly winds, 160. This is what we call the Kelvin wave generation area. It goes from about the date line to about 140. You build a box right here. If you get westerly anomalies, or in this fact, even real westerly winds, and these are in fact westerly winds blowing, warm water that's here starts falling to about 150 meters under the ocean surface, makes its way the whole way across the Pacific, and then gurgles up along the Galapagos Islands 3 months later. Here's anomalies, okay? This is actual winds from actual buoys sitting on the ocean surface. Notice, in fact, westerly anomalies in play, just as we suspected, and also what the models show. Warm water here, of course, 1 degree above normal, but also 1 degree above normal here, right on the equator and just north of it, and half a degree or more above normal the entire way across the equatorial Pacific. This is what is feeding the jet stream right now, and is in fact giving us a better than average storm pattern earlier in the year than normal, with already 3 solid swells having hit the U.S. West Coast, favoring the Gulf of Alaska and the U.S. West Coast. But at some point, we expect the Dateline area to start waking up, and Hawaii to share equally in all the generosity of the ocean. Water at depth. So we talked about warm water falling at depth. So here is actual water. So The X's are buoys strung up the whole way across the Pacific Ocean, and there's sensors down these buoys line, down depth, down to 300 meters, and so they can accurately get and all the buoys actually are linked via satellite, so you can get daily feeds off the buoys, actually better than daily, get water temperatures. So here's the actual water temperature profile, but it's the anomalies, differences from normal that we're really looking at. And so here you go. There's a pipe basically of 1 degree anomalies the whole way, going from the West Pacific down to depth, and then working their way up towards the Galapagos, which would be around right here. Notice 2 degree above normal anomalies here. This is in fact a Kelvin wave that has made its way the whole way across the Pacific Ocean. Started in the July-August time frame. It's now gurgling up along the Galapagos. Also notice a second Kelvin wave, 3 degree anomalies, just down at about, centered about 170 west. It is working its way east as well. And the westerly winds, if they continue to blow, will push yet more warm water down here and create yet more Kelvin waves and feed the jet stream. Let's keep going. Here's another view, modeled view, same situation. Notice warm anomalies working their way up into the Galapagos, and yet the next Kelvin wave building under the dateline. We like this chart a lot here. Same thing over time, November last year, and this is upper ocean heat anomalies. That is the upper 300 meters of the ocean, heat content over time, let's see, there we go. There's the far West Pacific here, 140 east, and the Galapagos about here. Notice this is a Kelvin wave. Warm water moving east. That was about a year ago. The massive Kelvin wave that happened January, February, March, pushing east. Then, and also notice upwelling Kelvin, the upwelling phase of the Kelvin wave, cool water in between. And then here's the mini Kelvin wave that's currently impacting Ecuador or close to it right now. It actually hasn't even quite made it to Ecuador. It seems like it's probably gurgling up at the surface somewhere west of Ecuador. And then here's yet the next one forming. And notice it is in fact moving east here, not making a lot of headway, but it's doing it. So when you see Kelvin waves, that's certainly not the La Nina. During La Nina, you'd have nothing but easterly anomalies. You'd have nothing but cold water. You wouldn't see any of this. And when things are neutral, you'll get little tiny Kelvin waves starting to push across. When you get El Nino, stronger Kelvin waves. And all this means more warm water warming the ocean surface in the Nino 3.4 region. Here's a model version of what water temperature anomalies are going to look like in November. Notice slightly warm. Okay, Nino 3.4, we've talked about that. Starts about 120 east, goes a couple of degrees either side. You put a box and go right like that. And if you have average temperatures half a degree above normal for multiple months in a row, 3 months I think they used, or is it 5 consecutive 3-month running averages, then they declare El Nino. We're not there. There's been not cool water, but normal water that's sort of been pooling up on occasion here. We seem to be over that hump now. From this model depiction, you go, yeah, for sure El Nino's in play. Notice all the warm water modeled to be built up along the coast in November, and you know, we're practically there. So this is a pretty good sense of what's going on. Let's take a look into the future. By February, here you go. If the Nino 3.4 region is like this box here, then certainly warm water, what's that, about half to 1 degree above normal would be in this area. They'd declare that El Nino. Also notice warm water temperatures to persist even in February, several degrees above normal along the entire U.S. West Coast. Certainly good for lighter wetsuits in the winter. And yet even more interesting, here we are forecast in April continuing to warm to 1 degree above normal. This is interesting. Typically, if you had El Nino, this would all be breaking down by about the March, April time frame and falling apart. But we suspect this. So, and also, if it was a classic El Nino, the warm water would really start here and sort of be bowing off like this. but instead it's just supposed to pull up out here. This is more of a Modoki El Nino, a sort of El Nino, not really El Nino. It's like the precursor to El Nino. Sometimes you can get these Modoki El Nino scenarios that go for a year, 2 years. They back off for a year a little bit, then they come back as a real El Nino in the 4th year. And this, if one is to believe the models, that's what the suggestion is that we're moving into. And that is very good, because warm water in this region, what it does, it actually feeds the jet stream over the Pacific Ocean, and specifically in the Gulf of Alaska in winter months, creates stronger than normal storms, more of them, which ultimately results in more surf, longer lasting swells, and a long string of them. And if things are particularly empowered, you get higher than normal precipitation. But when these events go for 1, 2, or 3 years, what happens is the jet stream sort of digs into a pattern and just gets going. And once it gets the momentum behind it, it doesn't stop. And so then you get like a machine sort of set up year after year. It just starts pulsing. You talk to the old timers that have surfed for years along the U.S. West Coast and even down into the tropics. They can tell you the same thing. El Ninos and even the Modoki El Ninos, they warm the water, just like what we're seeing, and the storm track and the swells that result from them are much more frequent, more intense, and longer lasting than anything you'd ever see during a La Nina year. So this sort of looks like a setup to a Modoki El Nino and maybe a multi-year sort of event. And then finally, the long-range prediction from the CFS V2 model, Nino 3.4 region, average water temperatures. So here we are in October, at almost the end of October, about half-degree anomalies. And notice this, again, it's a model, take it for what it's worth. January, again, about half-degree anomalies in that region. But then you get into April and we're, what, about 0.7 degrees, 6.5, something like that. But then notice the upward trend in July. If you were going to have a real El Nino, this is what you expect. In the July time frame, things really start taking off. Of course, notice there's runs of the model that say higher and lower, so who knows? But what this definitely suggests is water temperatures aren't going anywhere this winter. We're already there. Things are, the die is cast, the momentum's in place, and we would expect to see a pretty decent winter in terms of storm production, and also maybe reasonably decent in terms of precipitation, at least normal. The other thing to notice is when you get this sort of a setup the summer after even a Modoki El Nino, the southern hemi starts picking up on the atmosphere in the momentum, and it tends to be a little bit more productive. Certainly we can't be any less productive than we were last summer. I mean, summer never even really started in the Pacific Ocean until September. And then we had a good run of swells, but by then we were almost effectively into a fall type situation. Good run while we had it. Anyway, the models are very encouraging, looking good at this point in time for maybe a multi-year event. Take it with a grain of salt, but the pattern looks good. So to wrap this all up, put a bow on it, basically the short-term thing is swell for, let's say maybe next weekend, and some lesser energy prior to then. Nothing really big on the charts, but certainly not flat, something rideable, and that's always good. And then long-term, again, the Modoki sort of El Nino setup is what looks like happening. And pretty favorable for this winter. And snow-wise, we'll see. Maybe the first event by next weekend for the Sierra, and rain as well. So things are looking much better. It seems like we're in a lot better place than we've been for the past 4 years. So that's it for now. Thanks for watching. We'll do this again next week, same time, same channel. In the meantime, go get some surf, have some fun. See you next week. Thanks.